Hello everyone, video 4 of module 2. We continue showing how to define sections. This video is mainly focusing on defining concrete sections for frame element and shell element. To create concrete sections, we coming to define section properties and we go to add new property and change this one to concrete. And then what type of concrete I want. So I want, for example, a circular column and a rectangular column. I will show both of them, and then a rectangular beam. So I'm coming to circular column. For circular column, I need to define the name. So I would say concrete column, just short, as far as you understand what you're doing. Concrete column, and then say, for example, 600 diameter. Yep. And then you can come here and say what's the diameter. Currently the units are in millimeter, so I'm putting here 600 diameter. And grade of concrete 50 MPa. And then I need to show the section properties here. So set modifier, I'm coming, this is because of this is column. Generally for crack control section, your reduce stiffness is 0.7. For bending, I press OK. So this time is fixed now. And then section properties are here, but you can come here for concrete reinforcement. You can define the reinforcement here. Grade of rebar, currently we just define one grade of rebar. So for tie and for longitudinal bars are the same. You can add, for example, lower grade, for example, 250 for rebars. It's up to you. Because this is circular, so it's to tell you what type of design you want. Because this is column, it's going to moment and axial and moment interaction, and then column is circular. You can use either ties or spiral for circular column. Then what is the concrete cover, reinforcement bar, and number of longitudinal bars. So I will keep this one 8. And what's the size of the bar? So the size of the bar for us, standard Australia is based on N. That means 20 millimeter or 24. For example, I will put 8 and 24. And then here, what's the size of the fitment? I can come here and select, for example, N12, which is 12 millimeter. What's the space between the bars? Say 300 millimeter space between the bars. And here is up to me. I want to check this section, or I want to software to design the section. My preference always is reinforcement to be checked, but it's up to you. If you want to put reinforcement to be designed, then actually it's not very important that what you are putting here, because software automatically calculate the reinforcement rate for you and give you the options. But because I defined everything here properly, I will put reinforcement to be checked, and I press OK. And I'll change the color of the column to, for example, this, and then press OK. So this is concrete column. The name is really up to you. I'm just showing how you do that, but currently, for example, my preference generally is a bit simpler, so I can put CC, is concrete column, as a name, which is because when you have too many elements in the model, if it's a long name, it's very hard to read it. So better to make it smaller. So this is for concrete column. Again, I'm coming here. If you have other circular columns, simply you can use add a copy of property and do that. And one thing I generally show here that I forgot to say is grade of concrete. So it's 50 MPa. So whenever I see these names or this color, I'm clear what type of column I'm dealing with and what's the concrete grade. Now I want to define a rectangular column section. So I'm coming again to add new property, and I'm using concrete rectangular. So you can see it doesn't give me the option to check the material, so I need to check it here. So I'm coming here again, CC, say 400 by 640 MPa, for example. And then I'll choose a different color for that. For example, this, and then I'm coming here, make it 400. So depth is 600 based on my definition. You need to set a rule for yourself just for your ease of understanding. If you have a team, you can actually standardize this. That's what I did for my team. So here is 600 height, 400 depth, 400 width, and now I'm changing this one to 40 MPa, and then coming to set modifier as I did before. So 70% I'm using for stiffness, and now coming to concrete reinforcement. Concrete reinforcement rebar is the same, it's the column, so we're not, because it's rectangular, it gives you beam and column option. Keep it for column, rectangular, ties, and the clear cover to confinement bars. So this is for confinement bar. So this is the cover coming to the confinement, then you have a size of confinement, and then you have the reinforcement. So if you want to see the distance of the center of main bar to the edge, that would be half of the bar diameter plus the size of the confinement bar plus the cover. That's how you can calculate. So we can keep it, say, 30 millimeter for this one, and the number of longitudinal bar along 3 direction. So when you said number of bars along 3 direction is these bars, which is along 3 direction. So keep it 3, and then number of bars along 2 direction face, which is this. I want to change it to 4. And size of bar, I will change it, say, N28. And then I'm coming here, change this bar to N12, and you can add the size of bar if you missed anything. For example, you need R10 or any other size that you want to use in your local standard, you can add it here. I'll show you later. Longitudinal spacing of the bars, let's say 250, and then this is reverse of this, number of confinement bars in 3 direction. So when you say number of confinement bars in 3 direction, means confinement bars in this direction. I have 4 bars. It really back to the regulations of confinement of the bars. In Australia, if this distance between the bars are more than 150 millimeter, you need to confine all of them. So I will currently confine all of those bars. So I would say in 3 direction I need 4, in 2 direction I need 3. So I keep it as it is. Again, reinforcement to be checked, and I press OK. So you can see this arrangement change to what I want. So everything is set, and I press OK. Now I want to introduce a beam section, concrete beam section. So I'm coming here again to add new property. I'm using rectangular, and I change this one, for example, to concrete beam, say 400 widths times 700 depths, 40 MPa. And then I'm changing this color to, say, this color, or a little bit darker, like purple. And then I'm coming here and change this depth to 700 and width to 400, and then change the concrete grade to 40 MPa. And then in set modifier, what I need to do, because beam is under heavier moment and generally there is not much axial load, the crack section is more severe, so it's coming to 35%. So this is the moment of inertia about 3-axis or 2-axis. So moment of inertia about 3-axis in the strong direction, moment of inertia about 2-axis in the weak direction. So I'm choosing the strong direction, 0.35. I can leave the other one as 1. And then I'm coming here, going to concrete reinforcement. So concrete reinforcement, so the rebar for tie and longitudinal is the same, but this is not the column design, this is a beam design. Just bear in mind, when you are in column, the clear cover for confinement bars are asked. But when you're going to beam, the concrete cover to longitudinal rebar center actually will be asked. So what you need to do, you need to calculate yourself. For example, you have N24 as a longitudinal bar, so half of a diameter is 12 millimeter, then you have 12 millimeter confinement, that's 24 millimeter. Say you have for example 40 millimeter cover, so totally they come up with 64 millimeter. So I need to change those covers to 64 millimeter. And this reinforcement override for ductile beam, back to the local regulation you have for ductility. If you need to add them here, you can, but we will leave it by now because this is for advanced session. So these are the frame sections, concrete sections we wanted to have. Now we are going to create a wall section and a slab sections. To do this, we need to come to define area section here, or we can come to this area and use section property and area section. So we have few options here. We talking about shell, so we're going for add new section. So we want to, for example, define a slab section, a 200 slab section. So I mentioned 200 slab, 40 MPa. And there are a few options here. I can change this color, as I said, for shell. I'm going for lighter section. What I can do, I can come here and say define custom color and make it lighter. If I want to, for example, come to here, and then here there are a few options: shell thin, shell thick, plate thin, plate thick, and membrane. So plate generally is the element that can just take out of plane moment and shear. Membrane is the element that cannot take any out of plane moment and shear, and membrane just have in-plane actually stiffness. Shell is the element that can have both out of plane and in-plane moment and shear. So it really backs to how you want to define it. For wall, definitely we need to go for shell. For a slab, you can use plate, but because of the lateral stiffness of a slab you have, if you want to go for semi-rigid option and show the internal forces of the earthquake in the slab, you need to use shell. If you are defining the rigid diaphragm and you don't have any internal force in plane, then you can use plate. And when you can actually the thickness is not very high, and roughly the size of your mesh is comparing to the thickness is high, you can use thin. If the size of the mesh comparing to thickness is not very high, for example the thickness is 1 meter and your mesh is 1 meter by 1 meter, then you need to use shell thick. The difference between these two are the difference in shear forces. So because the slab is just 200 millimeters, so we use shell thin and change it to 200. Membrane means just in-plane forces, and bending for out-of-plane forces, so we put both of them 200. Change this one to 40 MPa concrete, and then those are the options for advanced, so we will leave it. Modifier, again, it really back to how actually the slab will behave, but generally because of the crack and long-term deformation, we use the modifier 0.35 here, 0.35 and 0.35. So those are for set modifiers, and those are shell design parameter. This is actually, we will discuss about this shell design parameter later. This is a powerful tool in shell design, but I will leave it by now. So that's all. This is your slab, and you just need to press OK here. So you have 200 slab for 40 MPa, and you can add another section we can say, for example, 200 wall, 50 MPa, for example. Color could be generally a strong color, so you may go for example this, and you can change these colors later if they are similar or anything that you want to change. It's not a big deal. Coming here, use 50 MPa and set modifier. If you want to change the stiffness of the wall, it's really back to the type of wall. If it's purely load bearing wall, it could be 1 or could be maximum 0.7. But because we're talking about in plane moment, not out of plane moment, you don't need to change those. You need to come and change F22. So F22 0.7 is for the load bearing wall under a little bit moment, and we keep it shell thin here again, and I will create another wall for you. I would like for a core wall, for example, and coming here, so say 250 core wall, 50 MPa, and I change the color to something dark, and here's 250, this is 50 MPa. You need to check what is the bending comparing to axial load. If the bending is very high and axial load is not too much, then you need to change this modifier to even 0.35, like bending for the beam that you had. If it's a bit higher, you can go for up to 0.5 or 0.7. It's really back to the loads you have. So I've just currently I put 0.5, and that's all. If you have, for example, a foundation, the thickness is more, then those stiffness factors are different, and you may use shell thick. So I leave that one by now, and I will just keep going for the slabs. If I want to have a actually plate or membrane that I want to use it for some one-way slab, for example, one level I want to have a kind of composite section, and I want to transfer all loads just to the secondary beams. So I can come here and add a new section, and I said, for example, 160 slab 40 MPa. I'm just using 40 MPa because I have 40 MPa, but generally concrete slabs are, if they are reinforced, slab in Australia is about 32 MPa. So I'm using this 160. Again, those thicknesses may be changed because of the fire regulations. You need to check your local standards. So I'm using concrete 40 MPa, and then here I can come and use membrane. When I use membrane, that means there is no out of plane stiffness for that shell element, and all loads will be distributed between secondary beams and main beams. But if I choose plate, that means there is an out of plane stiffness, so plate itself redistribute the loads between other elements around. Changing the color to something lighter, playing with this a little bit, and then I press OK. So I have a slab for my composite beams, I have a normal slab, I have load bearing wall, and I have core walls. Now I want to show you what's the advantage of having different colors. For example, if those walls up to here are actually core 50 MPa, so if I come and I need to go to assign and assign area and assign area section, so I can choose 200 wall 50 MPa and apply. Okay, so you cannot see anything here specific currently because the color is set based on the object. So just assume this is, for example, a core wall, and I want to change this. So I can either go to this assign menu, area, and assign section, or I can come here and use this one. They are the same. So I just using Corval 50 MPa. Apply. OK. Now I define my slab sections. So I'm coming here, choose this one, 200 slab, 40 MPa, apply. And I'm going upper level to show my membrane, so I don't have any slab here. I can simply draw a slab. Here to this area, and then here. Okay, so it's taking between grids, so I think because it's a bit congested, sometimes it's confused. You just need to be patient. If it doesn't work, you need to do it one by one. Okay, so I will select all the shells. Doesn't matter if you select frame elements or not. And then you come in here and use 160 slab 40 MPa. Apply. So if I want to see the sections here and make them clear, I need to come here in general option, and instead of using color by object, use colors by sections. And when I apply, you see different colors here. So these are for different walls. I didn't assign anything here, so this is by default, but you can see these two are different. And I can do the same here for this, and you see all of them are purple, and the below ones, this level, are almost something between green and yellow. So those are the good things for you to figure out if there is any mistake when you assigning sections, or if you miss any element to assign the section. It's clear that these elements are not correct and they haven't been actually assigned to any specific sections. Likewise, the other levels that we had a slab, here we don't have any specific section, so you can find your mistakes easily. And we can do the same for columns. For example, I may choose all columns here at this level as a concrete column. So I can come here, or I can actually assign them by using this assign frame section, or I can come to assign, go to frame, and again assign frame section. So for example, I can choose 600 diameter, 50 MPa, apply. You can see the colors are different. Then I choose this one. I don't have any column here, so I can come here. For example, I choose this level, 400 by 600 column. You see the colors are a bit close actually in terms of colors, so that's what I said. You can change these colors to make it more clear for yourself. And the same for beam. If I choose, for example, these beams here and apply this one, you can see the color is changed. So you need to play with the color, just make it clear for yourself to see exactly what's going on. Also, what you can do to see some sections more clearly, let's define some steel columns, then I can show that one to you, that by extruding elements you can see a better section. So I choose some steel sections here, for example 250 UC, and then those are beams, say 250 UC 31. Apply. Okay, now if I select this view and show selection only and go to 3D, now if I come here in set display option, go here and use extrude and apply, you can actually see the sections here. So if I become closer, you can see this is an I-beam, and you can clearly see the sections here. So you can see this is I-beam, and then if I go to here, you can see this is concrete section. Or likewise for here, you can see this is circular section, but here is rectangular section. So these colors and those shapes help you to figure out if there is any mistake in assigning your sections. So this is the end of video 4 of module 2. We discuss about actually how to define materials, how to define sections, and how to assign sections. And in next video, which is for module 3, we start defining boundary conditions and talk about soil property and foundation.